Next problem, the PST of a random process is given by S omega, which is equal to pi if modulus omega less than or equal to 1, 0 otherwise. So given S omega, which is equal to SSX of omega, which is equal to pi, omega lies between minus 1 and plus 1, 0 otherwise. This is equation number 1. We know that R of tau, which is equal to 1 by 2 pi integral minus infinite to plus infinite S of omega e power I omega tau d tau, because R of omega is the inverse Fourier transformation of S omega, right, which is equal to 1 by 2 pi integral so minus 1 to plus 1 pi cos omega tau plus I sin omega tau d tau, because given S omega, which is equal to pi if omega lies between minus 1 to plus 1. So lower limit minus 1, upper limit plus 1. And we know e power I omega tau, De Moivre's theorem, cos omega tau plus I sin omega tau. So splitting the integral into 2, so taking pi outside, pi by 2 pi integral minus infinite minus 1 to plus 1 cos omega tau d omega plus integral minus 1 to plus 1 I sin omega tau d omega. We know cos omega tau is an even function, so you applying the property of definite integral, which can be written as 2 integral 0 to 1 cos omega tau d omega. So pi cancel, you will get 1 by 2, 2 into 0 to 1 cos omega tau d omega. And we know sine is an odd function as per the property of definite integral. Integral minus 1 to plus 1 sin omega tau d omega, which is equal to 0, right. So we will get 2 and 2 cancel, R of tau, which is equal to integrating cos omega tau d omega, we will get sin omega tau by tau, limit 0 to 1. So applying the upper limit, which is equal to 1 by tau sin tau, upper limit 1, right, instead of omega we are putting 1, so we will get sin tau. Then minus sin 0, instead of omega we are putting 0, sin 0 0, so we will get 1 by tau sin tau. This is R. Next problem, if the PSD of WSS process is given by S omega, which is equal to B by A into A minus modulus omega mod omega less than or equal to A, 0 mod omega greater than A, find autocorrelation function. So here they have given S of x, right, S of omega, right, S of omega, which is equal to B by A into A minus modulus omega. So omega lies between minus A to plus A, 0 otherwise. This is equation number 1. We need to find R. R of tau is the inverse Fourier transformation of S. So is equal to 1 by 2 pi integral minus infinite to plus infinite S omega e power I omega tau d omega. Substituting the value of S omega in the integral, so 1 by 2 pi integral minus A to plus A, B by A into modulus omega e power I omega tau d omega. Taking B by A outside because constant with respect to the integration, so B by 2 pi A integral minus A to plus A minus mod omega e power I omega tau d tau. Expanding e power I omega tau using De Moivre's theorem, cos omega tau plus I sin omega tau into d omega, right. Now A minus mod omega cos omega tau, so splitting the integration you will get, which is equal to B by 2 pi A integral minus A to plus A minus mod omega cos omega tau. We are taking that part into d omega, right. A minus mod omega cos omega tau is an even function, because you are replacing minus omega instead of omega, you will get the same one, so that is an even function. Then second one, A minus mod omega sin omega tau, second integral B by 2 pi A minus A to plus A minus mod omega I sin omega tau d omega, right. Here sin omega is an odd function, A minus mod omega is an even function. So multiplying odd and even, you will get odd function. So again we are going to apply the properties of definite integral. So you will get, so integral minus a to plus a minus mod omega cos omega tau d omega becomes 2 times integral 0 to a minus mod omega cos omega tau d omega, right? Plus the second integrand is an odd function. So you will get by the properties of definite integral that value is 0. So 2 and 2 cancel. You will get b by pi a integral 0 to a minus, in the positive value 0 to a, mod omega is nothing but omega. So omega cos omega tau d omega, which is equal to b by pi a integral 0 to a minus omega cos omega tau can be written as the derivative of sin omega tau by tau, right? We are using integration by parts u dv. So u dv which is equal to integral u dv which is equal to uv minus integral v du. So applying b by 2 pi a, sorry, b by pi a uv. U is nothing but a minus omega. V is nothing but sin omega tau by tau. So uv a minus omega sin omega tau by tau, lower limit 0, upper limit a, minus integral v du. V is sin omega tau by tau into du. U is a minus omega. We know derivative of a minus omega, which is nothing but minus d omega, right? So applying upper limit, so instead of omega you are putting a minus a 0. So upper limit, whenever you are applying the upper limit here, so you will get 0. Whenever you are applying the lower limit 0, sin 0 0, so 0 into something 0, so you are getting 0. 0 minus 0 minus 1 by tau is constant with respect to that integration. So taking outside minus 1 by tau integral 0 to a sin omega tau into minus d omega is equal to b by pi tau a integral 0 to a sin omega tau d omega. So we are taking minus outside from minus d omega. Already you are having minus outside, so minus into minus plus, right, is equal to b by pi tau a. So integration of sin omega tau is nothing but cos omega tau by tau, right? So minus cos omega tau by tau is lower limit 0, upper limit a. So applying lower and upper limit. So we are taking tau outside, b by pi tau square a minus applying upper limit a instead of omega. So minus cos a tau minus applying lower limit minus cos 0. Cos 0 1 minus into minus plus. So we will get b by pi tau square a 1 minus cos a tau. So we know 1 minus cos 2a which is equal to 2 sin square a by 2. Here a is nothing but a tau, right? So we will get b by pi tau square a 2 sin square a tau by 2. So therefore the autocorrelation is 2b by pi tau square a sin square a tau by 2. Thanks. We'll see in the next video.